Okay, folks, we want to determine if we have a bad pump or a bad water sensor. Now, what I'm going to ask you to do is remove the lid from the machine. If we remove the lid from the machine, the first thing you're going to see is this setup right here. So this is your water sensor, and this is your wire that goes to the water sensor. If your pump is not running, what I'm going to tell you to do, if we don't hear the pump, the first thing I want to know is, do we have a heat issue? Do we have a water fill issue? It's one or the other if the machine's not making steam. So the easiest thing to do first is to drain the boiler. With the machine cold, we're going to drain the boiler from the bottom. You can take your drain plug out, let any water run out, monitor how much comes out and how dirty the water is. So we're starting with an empty boiler. Put your drain plug back in. Now the boiler is empty. Now we turn the machine back on with a full water tank. We turn the machine back on. The pump needs to run at this point because the boiler is empty. If you do not hear the pump run, then we either have a bad pump or we have a bad water sensor. If the pump runs, hopefully the pump is strong enough to fill the boiler, and we'll know that within a minute or two. If the pump does not run, when you turn the machine back on, it could be a bad pump, but it could be a bad water sensor. It's either or. We're going to determine that by taking the lid off the machine. Here's your water sensor wire. Machine off. Good idea to unplug the machine. Unplug the machine, machine off. Wiggle this wire off your water sensor. Now, sometimes these get corroded. This is brand new. I can't even get it off. Wiggle it and pull it at the same time. We don't want to break the wire in the connector. Leave it off to the side. There's no voltage going through that wire. Plug the machine back in. Turn the machine back on. We're bypassing the water sensor. At this point, if the pump does run, the pump will be good, or we're going to assume the pump is good. We want to make sure that the pump still moves water. But if the pump at that time turns on, we can probably safely say that the water sensor is no good. Then if you quickly plugged it back in and the pump stopped, then we know that the water sensor is grounded out. So if the water sensor is grounded out, now we have to replace the water sensor. Water sensor really is a piece of cake to replace. But if you notice, we don't want to do this wrong. Now, when I send out water sensors, I test them. I test them for continuity. So I test a water sensor like this. From this tab to that shaft, I test for resistance. There's always got to be some kind of resistance here to make sure that the water sensor is good. And it's going to be tested before I send it out. So I know that the water sensor is good when I send it out. If the water sensor was grounded, I'd have an OL, I'd have an open line. Grounded means it's not going to turn the pump on. When I send you the water sensor, I want you to remove it from the boiler by this bottom nut. See how it screws into the nut like this? We're not loosening and tightening from that top nut. That's an adjuster sleeve for the shaft. We're loosening and tightening the water sensor from this nut right here. So get it out, and getting the old one out doesn't really matter how you get it out. So now the old one is out. You have the new one in your hand like this. I've continuity tested it to make sure that it's a good water sensor. We're going to drop it in the boiler. Now, if the water sensor grounded itself out, you can't really do this wrong. But again, going back to our steel shaft inside the boiler, if for some reason this steel rod was making contact with that steel shaft, then the water sensor would ground itself out. It would never turn the pump on. But because you're just dropping it straight through, and once the threads are lined up, that shaft is going to go straight down and never make contact with these walls. Now, tightening the water sensor, again, we don't want to tighten that nut. We want to tighten this nut. Now, you're going to have to compress your insulator, which we don't have on this demo piece here. So you want to get your wrench on this bottom nut, tighten it, tighten it, tighten it, tighten it until it's nice and tight. This nut should already be tight. We don't want to make it any tighter, because if this nut was too tight against that plastic sleeve, this nut is going to make contact with that shaft. It's going to ground it out. The water sensor is going to be no good. I've seen this before, and it's confused me. And I didn't let the customer know, so it's not totally their fault. The customer has tightened the water sensor by this nut. Tighten it, tighten it, tighten it, tighten it. Now, you will get this nut to move at the same time if you tighten this nut, but you're going to get to a point where you got to get it really tight. This is going to continue to turn. It's going to squeeze through this plastic sleeve, making contact with this steel shaft, grounding it out, and now making the water sensor no good, and the pump is not going to turn on, and you're going to be mad at me because I sent you either a defective part or I diagnosed the problem wrong. Chances are I didn't diagnose the problem wrong, and I know I sent you a good water sensor because I continuity test them before they go out, and I make sure that this nut is tight. So we don't need to touch this nut. We're only tightening and loosening it by this nut. Now, sometimes I'll tell you that the water sensor might be dirty. If the boiler is dirty and it's doing the same thing, it's overfilling the boiler where you're actually seeing pressure on your pressure gauge, that's not steam, that's excess water, because the water is rising to a level in the boiler and it's coming out through one of these fittings, and one of these fittings leads over to your pressure gauge. It's filling the tube up with water and putting pressure on your pressure gauge, giving you artificial pressure on your gauge, not steam pressure, water pressure, because the boiler is actually overfull. Because this water sensor is too dirty, it's either corroded with rust or it has way too much calcium on it and it can't read the water, allowing the water to get past the water sensor, overfill the boiler, the pump is never going to shut off, and your alarm is going to come on. So sometimes a quick fix, I'll say take the water sensor out of the boiler. So we take the water sensor out of the boiler, and I'll tell you only to take the water sensor out by this nut. So now if you do see some of this corrosion here, either take a piece of emery cloth, 80 grit, 100 grit sandpaper, and sand this entire thing. Sand the entire shaft, sand that little button right there, get it nice, clean, fresh metal, and also sand your connector here. Sometimes these connectors get corroded, so sand that also. Then you can put it back in, and this might avoid having to put a new water sensor in and then try it again, and hopefully at that point, the water sensor will see the correct water level in the boiler, stop the pump, and then it's going to transition into heat mode, and everything should heat and you should develop pressure.